1, and we're going to focus on continuity and discontinuity. So let's start with the definition of what continuity is, and hopefully it's making you think of continuous, because that's exactly what you should be thinking. Continuity. Alright, so continuity is the idea that a continuous function has no breaks, holes, or gaps. Essentially, you could trace the whole thing oh, that is not how you spell whole. Without lifting your pencil. Okay, so continuity is easy to spot. It's just completely continuous. So let's talk about discontinuity and discontinuous functions. Now, there's 3 different types of discontinuity. There's infinite, there's jump, and there's removable. Careful to take good notes here so you don't mix them up. So infinite, jump, removable. And we're going to make a little sketch of each so you've got a good visual on what they look like. So I'm going to make 3 cute little coordinate planes. And these are just going to be sketches. But make sure you do a good job making your sketches. We don't want you to mix these up. And then this is what I love about pre-calculus. This is all going to come full circle, and we're going to talk about this more at the end of the year. But for now, we're just going to dip our toes into it. Oh, jeez. That was terrible. I'm very tired this morning, guys. I'm recording this Friday morning. Okay, so on each of these graphs, there's going to be some point C. I'm just going to put it in the same spot. It is not always in this spot. C is just representing a x value, a random x value. So infinite discontinuity is when at C, the function increases or decreases infinitely. So over here, if we're coming from the left, it decreases infinitely, right, because we're going towards C. And then if we were coming from this way, going towards C, it's increasing infinitely. So looking towards C. So let's take notes on that to make sure you've got that solid. So at x equals C, the function increases or decreases infinitely as x approaches from the left and right. So from left and right of C. Okay, jump means at x equals C, the limit of the C value exists, but there's two different values. So that'd be like if I had an open circle here, and then it went off infinitely, but then I had a closed circle here, and it went off this way infinitely. So at C, the value does exist, but there's a big jump between the two, right? So they're not actually continuous. The domain would be written continuously, but the function itself is not. So let's write that down. At x equals C, the limit, and we'll talk about limits in a second, the limits of C exist, but have two different values. Okay, and then let's talk about removable. Removable means there's a hole at C, but it's continuing everywhere else. So my function might look like this. Right? It's almost continuous, but there's a hole. So function is continuous everywhere but where x equals C. And then these guys are called, like, we can put them in their own little category of just non-removable. Okay, so those are your three different types. Word limit, in case you've never heard it before, which honestly I can't remember if you have or you haven't. So the idea of a limit, so the concept, let's do limits real quick. Limits. So the concept of approaching a value without necessarily ever reaching it is called a limit. So if the value is getting really close, the notation is limit as x approaches C of f of x equals some value L. So in this situation, so this is red, as I just said, the limit as x approaches C, the limit of f of x, sorry. The limit of f of x as x approaches c is L. And c is just an x value, and L is the y value. So the concept is like for like removable discontinuity, right? So C doesn't exist, but as you approach from the left and you approach from the right, it's getting really, 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 really close to what y value. Okay. All right. So that's the idea. Let's talk about continuity tests because that's what we're going to be focusing on. We're going to be testing for continuity. There are 3 required things. So the first thing you are required to do is figure out, is f of c defined? Okay, this may not make sense yet because we haven't done an example, but it will. So then the second thing you have to do is make a table. Okay. So f of x is gonna, well, for our table, we're basically trying to figure out, does the function approach the same value from either side? Okay. And then the third thing we do is we make a conclusion. And then we have to write a limit if we can. Okay. So if it's continuous, approaches C, and make sure your notation is correct. So limit has x approaching C under it only, of f of x, so of the function. So as x is approaching some number of our function, the y values are going to exactly what f of c equaled in the first place. So if it's continuous, it's going to go exactly to that spot. If it's not continuous, it's going to some number or not, but we'll talk about that. So that's it for today. I know we haven't done any examples and you might be a little bit confused, and that's okay, but we're going to do some examples tomorrow and we're going to really emphasize all of this. So make sure you have all of the instructions written down very neatly, and double check that all of this is written accurately because you're going to want to have this as a resource when we're doing our examples.